Okay, today's lesson is on Chapter 9, Lesson 2, where all of Chapter 8 was adding fractions with like denominators, unlike denominators, adding with mixed numbers, having to regroup. So now we're going to be getting into subtraction. So our objective today is to rename a whole number as a mixed number to help us subtract. So in Lesson 1, they gave the modeling, which we already kind of know how to do because we learned it in in Chapter 8. So we're just going to look at the mathematical way of doing this, and then I'll model what the modeling looks like in this lesson. Okay? So, with the fraction tiles. In this lesson, you will practice renaming to subtract mixed numbers from whole numbers. So the example talks about the Guzman family needs 5 bags of cement. 5 bags of cement. For their patio. They need 1 2/3 bags for their, so this is for the patio. And then they need 1 2/3 bags for the front porch. So just that front portion. How much more do they need for their patio? So if they've already used 1 2/3 bag for the front porch area, how much more do they need for the patio? So in that question, the how much more do they need for their patio, what are the key words there that tell us that this is a subtraction problem, that I should be using the operation subtraction? Varsha?
How much more?
Right, that how much more, okay? Because when you're saying how much more, you're saying comparing two things, right? How much more of what do you need when you already have something, right? How much more tells us that we need to subtract, all right? Do they need for their patio? So the problem becomes 5 bags minus 1 2/3, because they've used 1 2/3 and they know that it takes 5 bags total. So how much more do they need to get this patio done? Okay, so when we look at the problem, and when I look at it horizontally, you can do it this way, but I'm going to switch it so that it's vertical. So I have 5 minus 1 2/3. So I'm doing this because it shows me visually what I'm trying to do. And right here, next to the 5, do I have a fraction here? No, it's not a mixed number. It's just the whole number 5, right? So if there's nothing there, essentially it's the same as saying what number?
4 and...
Nope. 0. Very good. It's essentially, you have to think of it as if a 0 is there. And if I have nothing there, can I subtract 2/3 from nothing? No, that's not possible, right? If I have no candy, can I take away 2/3 of your candy? No, right? It doesn't make sense. But I know that I have 5 whole bags of cement patio. So I can take away from the 5 whole bags of cement. And I'm going to take, just like you do in normal subtraction, 5 is then going to change into a 4 because I'm going to borrow 1 bag of cement and I'm going to give it over to the fraction. Okay, so instead of a 1, how am I going to change that 1 into a fraction? 1 is equal to what as a fraction? Now, to make it easy on yourself, what should the denominator be?
3.
Why 3? Why 3?
Because that's the denominator we're working with.
Right, that's the denominator of the fraction that we already have and are working with, right? So if we have 2/3 and the denominator is 3, why would we want a different denominator, right? Adding with denominators that are the same rules apply to subtracting. You need the denominators to be the same, okay? But what's the number that goes on top? What's my numerator going to be? What is 1 equal to in thirds?
3.
3/3, right? 3 divided by 3 is the same as saying 1. Numerator, denominator, same number, equal to 1. So now, instead of it being 0, I'm going to rewrite the problem, and now it's 4 3/3 minus 1 2/3. Okay? Now, do I have a problem that I can subtract with?
Yes.
Yes, I do. So I'm going to take 3/3 and subtract that by 2/3, and I get 1/3. Very good. And now I subtract the whole numbers. 4 minus 1 is 3. So how many bags of cement do I need to make this patio? 3 1/3 bags for their patio. Okay, number 1 on page 189, we have the problem 6 minus 4 1/5. So again, to make this easier for me, I'm going to rewrite this problem vertically. So I have 6 minus 4 1/5. Okay, now I know that since I don't have anything here, I can't subtract from nothing, right? So 6 changes into what? 5 5/5. Very good. Because I look at my fraction down here, and I see that it's in fifths. So I want to keep it the same fraction, same denominator. Okay. 5 5/5 minus 4 1/5. Okay? So I'm showing. You guys need to show all these steps, right? You need to show what 6 turns into. And then you show how 5/5 minus 1/5 is 4/5. And 5 minus 4 is 1. I can check to see if my answer is correct by taking 1 4/5 and adding it to 4 1/5, and I should get what? 6. That should equal 6, right? 4/5 plus 1/5 is 5/5, and 4 plus 1 is 5, and 5 5/5 equals to 6. Okay? It checks out. So this is my check. I know that my answer is correct. I know that 1 4/5 is the correct answer. Okay, number 2 is 10 minus 8 4/9. So I'm going to rewrite this problem again going vertically. So I have 10 minus 8 4/9. Okay? So the 10 is going to change to a what? Take away 1 and becomes a 9. And then since I'm borrowing 1, what does that fraction change into? 9 9 ninths. Okay? Because 9 ninths is equal to 1 whole, and I'm only borrowing 1. Okay? Remember, every fraction is less than a whole, right? And the highest fraction that you can have is 1 whole, which is what we did with the 9 ninths. Okay, so then I subtract from 8 4/9. So 9 ninths minus 4 ninths is 5 ninths. And 9 minus 8 is 1. We can check by adding, correct. So 5 ninths plus 4 ninths is 9 ninths. 8 plus 1 is 9. 9 9 ninths is equal to 10. So I know that my answer is correct. Okay, so how would a model of this look like? Okay, so we have 2 wholes minus 1 1/3, right? And if we were going to model this to find the difference, when you look at A and B on page 187, which one would you want to use there, A or B? Which one makes more sense there? A or B?
For number 1?
Yeah, for number 1. A, right? A has 1 whole, and then it has another whole, but it's what? Broken up into thirds. Okay, so we have 1/3, 1/3, 1/3. So this is altogether, this equals 2, right? Now, if I want to take away 1 1/3, then I would take away the 1, right? I don't need that anymore. And then I would take away a third. How much do I have left? 2/3, right? So my answer should be 2/3. And that would be my answer. That's how I would see it visually. Okay? Let's try one more. So if I have number 3, let's look at number 3. I have the problem here. 2 minus 1 3/4. So I'm going to have one whole. And then I have another whole. But this time it's going to be split up into what? Fourths, right? Because I look at my fraction here and I look at the denominator and it's in fourths. So 1, 2, 3, 4. So I have it divided into fourths. Okay, one whole and then one other whole but as fourths. So it's easy for me to take away. So I want to take away one whole and 3/4. Okay, so I take away one whole, don't need this anymore. And then I take away 3/4. Don't need this, don't need this, don't need this. So what am I left with? 1/4. So my answer should be 1/4. Okay? And I know that's correct because 1/4 plus 3/4 equals a whole plus another whole equals 2. Okay? You can always check your answer by doing the opposite operation and adding it together to find out your first addend. Okay? So when you're modeling it, you guys can use, if you're stuck and you don't, you need to see it physically, you can draw the fraction tiles and subtract that way to help you. Okay? And you want to start with your first number, okay? You always want to start with what you have the most of, which is the 2 in this case, and take away from your whole, okay?